Thank you all of you for coming. Today I'm going to talk for you about PyKubeSlurm, which the name's a little bit intuitive for if some of you are familiar with the three frameworks related to it: Python, Kubernetes, and Slurm. And the content is related to submitting jobs to the Slurm queue by using Kubernetes. And I might be careful with the simplifying or efficiently part of it, because for some of you familiar with the Kubernetes environment and such, it might be simplifying or not, depending the workflow you adopt when submitting jobs to Slurm. So let's get going. A little bit about myself so you know what to expect. I'm a software engineer currently working for OmniVector Solutions. I have some experience by working at OmniVector with Slurm, HPC environments and such. And I'm also a person who does Kubernetes all the day long, like 5 days a week, just Kubernetes and all sorts of workloads, from deploying databases, messaging protocol instances like RabbitMQ and such, and also managing APIs and all of these sorts of things. So concatenating my experience in the last few years in Kubernetes with my experience in Slurm and Python, I came up with this tool that might be interesting. And yeah, that's pretty much it. I also have some strong emphasis in electronic engineering, not that much related to the talk today, but I also have it. Right on. Well, let's get started with the problem statement. I mean, for what's the idea of PyKubeSlurm? I mean, what's the problem it tackles, right? So, oftenly, submitting jobs to Slurm is not that easy as it seems. Let's say you have a Slurm cluster. Now, how do you make your engineers to actually submit their computational workloads? There are a million ways of doing that. I'm going to fill of them here. But sometimes adopting new technologies is something not easy for engineers. And by engineers, I mean like mechanical engineers, electrical engineers, and such, people who actually does the simulations, right? So there are a million ways of submitting jobs to a Slurm cluster. One of them is by using this interesting tool named Jobbergate, which I also helped to develop, but the main maintainer is not me. Fortunately, the main maintainer is in the audience. Glad you come. It's very interesting, built by OmniVector, and the whole idea is to template job scripts using Jinja 2, and you can submit them remotely to a Slurm cluster. Either way, right? It can fit your use case, your pipeline of workflow, right? Also, the most, let's say, common way of doing that is just by SSHing into the cluster directly, which might be very easy for software engineer like most of us, you know, SSH, username, host, and it's done, you're in. But believe, I've seen people struggling to do that, especially because they are not familiar with the software engineering road, especially in the university. I've seen people like really struggling to type a terminal command, to copying something from PuTTY and you know, running that. I've seen people struggle with that. So sometimes just doing it doesn't fit engineers' workflow. And that there are many more other ways, right? I mean, companies and universities have developed their own workflow actually to get jobs into this Slurm queue. So this is why this tool, which I named PyKubeSlurm, comes in place, which is essentially a Python operator built on top of Typer, which is a CLI tool, and threading to run multi-thread operations, which I will detail a little bit later. And the whole idea is to run as a standalone Kubernetes deployment. And by deployment, I don't mean exactly the deployment reserved by Kubernetes. It could be a stateful set, for example. If you are familiar with Kubernetes, you might know what I mean. It just needs to be deployed. It is designed to be deployed in Kubernetes, right? And it's open source. By the end of the presentation, you will have the links to access it. It's licensed under MIT. You can all access it and modify as much as you want to. So going in the details of the functionality of it, I'm not going too technically deep here, just a little bit. So there are some requirements to get it going, and especially because behind the scenes, it uses Slurm REST-D to submit jobs to Slurm. Essentially, for those not familiar with whom I'm talking to, Slurm-D is the REST API, which you can use to access Slurm resources. And by access, I mean you can also modify them or create new resources. So for that to work, let's say you have it deployed somewhere, right? It could be on Minikube, MicroK8s, or your bare metal Kubernetes service, doesn't matter. Somehow you need to access this Slurm REST-D endpoint. So in your network space, the Slurm REST-D endpoint must be accessible by PyKubeSlurm. It's kind of obvious if you think about that, right? The network protocol must allow it. And also, the network protocol is something that might disable engineers to get jobs into the Slurm queue sometimes, which is something PyKubeSlurm solves, because the engineer itself doesn't need to access the cluster network anymore, just PyKubeSlurm. The engineer could be in their home with their network, their home network, right? Also, the whole idea is to leverage the Kubernetes concepts, the Kubernetes resources. So now everything is all about creating a custom resource definition manifest, which I will just call CRD, custom resource definition. And PyKubeSlurm simply watches changes and creations and deletions in that custom resource definition. And by watching that, let's say when you apply a manifest, PyKubeSlurm is watching the string, and you will detect something was created or modified, and then do all of the things behind the scenes to communicate correctly with Slurm. And that's it. After that, the job submitted by accessing the Slurm REST API. And the whole idea behind it is to simplify in a way that job scripts can be now versioned using your version control. Could be Git, for example. This is something I had in mind because being a person who do Kubernetes all the day long, deploying like more than 600 manifests in a single Kubernetes cluster, it is essential to have version control over your workflow, right? Because sometimes you change stuff, and sometimes you need to roll back and such. So that's why I think, in my opinion, this is such a great thing, because you can leverage the Git workflow plus Kubernetes workflow to version control your resources, your job scripts, right? And going on. So after that, explain a little bit about the internals. It uses Slurm REST-D and so on. So think about a mechanical engineer, for example. Now, how your job does look like. I mean, you need essentially to submit a script to a cluster. It could be a Python script or whatever. How does it look like in practice? Well, I told you guys that PyKubeSlurm uses the Kubernetes concepts, and in essential, by deploying the standalone deployment of PyKubeSlurm, you also deploy a custom resource definition in the cluster. So by the end of the things, this is how your script might look like. So this is a simple example. There is a reference I got from Berkeley, and it's simply a Newton Raphson method to calculate the roots of this equation right here. Not going into the details of the script, it could be like literally anything you want to as an engineer, right? But the thing is, you can define all the Slurm REST-D parameters like as key value pairs You can define the nodes you want your job to run on. You can define the name. And I mean, all Slurm common parameters actually available by srun. Not all of them available by sbatch. Some sbatch has more parameters than they allowed by Slurm SD. But at the end, they will be the same. Going on. So what is exactly the benefits of using such a thing, right? As I said in the beginning, it might not fit your workflow. Sometimes your company or university already have a very well-defined workflow. It doesn't make sense to you. But being a Kubernetes person, by integrating Git workflows with Kubernetes, you can better manage your resources. You can take advantage of the Git versioning to do a better knowledge management for your research, for your product development, and such. And also, by being deployed on Kubernetes, you can also take advantage of the scheduling of Kubernetes. You don't need to care about the high availability and such. You can have auto-scale enabled. If some pod goes down, Kubernetes automatically goes up another pod, depending on the pod disruption budget you have created. And going on, where can you access PyKubeSlurm? There is a image which I published in Docker Hub in my personal account. Also, as I said, the project is open source. You can access it on GitHub. I have the links before. You can all easily access it. And I also done some documentation on how to get it deployed in your environment. I personally have run some integration tests using Minikube and MicroK8s. In MicroK8s, it wasn't deployed as a charmed operator. It was just deployed as standalone manifests. I didn't go too deep into like deployment details here. I mean, I really invite you to check the documentation later. There is some detailed instructions there on the requirements and how to get going. And well, as a Python project, what's coming next? So, for me, I guess the most important thing for now is to enable the deployment by a charmed K8s operator, so we can easily integrate with MicroK8s, for example. It works in MicroK8s already, but you need to deploy as a standalone manifest, right? And also next, you might have thought before, like supposing you have a job script that is too big, let's say 100 lines, which is not that big, right? So if you go to this, I mean, 100 lines in this file, for someone who is not that familiarized with Kubernetes, will be a very long file. I mean, difficult to read. For someone familiar with Kubernetes, will be okay. I mean, I've seen config maps with 1,000 lines, right? But it's not that visually great. So something coming for the future is the support for config maps. It's very common in the Kubernetes world that you put your files that you'll be used later in some deployment, stateful set or whatever in a config map, and then you just mount it to your pod, so you have access to the files. So this is definitely something that is coming for the future. Also, 100% unit test coverage for now. We're not getting there. And also more integration tests definitely coming for the future to integrate with different Kubernetes environments, which is essential in my opinion. For example, in bare metal, that's something I couldn't do. And well, not going too technical deeply today. That was I have for you. You can get in touch by my personal email, by my email, my OmniVector email. And for those interested, you can access all the source by the QR codes. And this is it. Thank you for your presence and attention. Maybe you have some time for questions.
Hello.
What is up, Jason?
Nothing much. So one thing I did want to ask is, first of all, I think this is very cool, kind of how you're able to integrate Slurm into Kubernetes. I guess the one question I did have is like, where are you running the other Slurm services? So like Slurmd, Slurm CTLD, is that also running on Kubernetes, or are you kind of proxying to like a bare metal or virtual machine cloud?
Okay, so all of this started with me trying to actually run the Slurm components in Kubernetes. I got it working, to be very honest, like Slurm CTLD, Slurm DBD, and Slurm REST. But somehow I couldn't get the auto-scaling nicely working, actually. So for doing all the integration testing, I actually used the Slurm charms that you demoed yesterday, using the Juju tree controller, actually. That was how I got the integration testings running. And I just needed to make sure to have it deploy in the same network space. That was how I did it. This is it. Thank you for coming.